Hi everybody, this is homework problem number 98 from page 374, and we're working on rational function big problems. And what I'm going to do this time is just talk through the solution that I've already written up. So you can see the problem here. We have our function f of x, and what we want to do to start with is factor it. And we know that x squared minus 16 is a difference of squares, so it factors into x minus 4 times x plus 4. And we know that x squared minus 9 is also a difference of squares, so it factors into x minus 3 times x plus 3. Now that we have all the factors, we look to see if there's any factors on the top and bottom that cancel. And as you can see, I already canceled the x plus 4s on the top and bottom, and the x plus 3s on the top and bottom. And then we write the reduced form of our function. So our reduced form here is x minus 4 over x minus 3. Okay, now we're going to figure out all the features of the graph all the features of the function in order to graph it. And since we canceled x plus 4 on the top and the bottom, and since there are no more x plus 4s on the bottom, we know there's a hole at whatever number makes that factor 0. And the number that makes that factor 0 is negative 4. So there is a hole at negative 4. How do you find the y-coordinate of the hole? Well, you take the x-coordinate, negative 4, and you plug it in to the reduced form. So negative 4 minus 4 is negative 8, and then on the bottom, negative 4 minus 3 is negative 7. Negative 8 divided by negative 7 would be positive 8/7. So that's where I got my y-coordinate. The same thing is true for the other hole. Because we canceled the x plus 3 and there's no more x plus 3 on the bottom, we know there's a hole at whatever x value makes that 0, and that would be an x value of negative 3. To find the y value of the hole, take the x value, plug it in to the reduced function, and that will give you the y value. Now let's move on to talk about the y-intercept. And you always find the y-intercept by plugging 0 in for x. And as long as you have a reduced form of your function, you might as well take advantage of that. Plug 0 into your reduced form, and you'll find your y-coordinate of 4/3. For an x-coordinate, you're going to plug in 0 for y, which essentially boils down to just saying what makes the top equal to 0. And go ahead and use your reduced form again. Look at the top. What makes it equal to 0? That would be if x was 4. So that's where our x-intercept is. Okay, now it's time to talk about asymptotes, vertical and horizontal. And remember that to find your vertical asymptote, you're going to look at the denominator and ask yourself what makes the denominator 0. And so that would be 3. So the vertical asymptote is x equals 3. And for the horizontal asymptote, you're going to look at the degree of the numerator and the degree of the denominator. The degree is the highest power of x, so the numerator has x to the first and the denominator has x to the first. Those are equal in power. It's not top heavy, it's not bottom heavy, it's the same. And when that's the case, then you look at the ratio of the leading coefficients. And so in front of the x you have an invisible 1. Down here you also have an invisible 1. So the leading coefficients are 1. And the ratio of 1 over 1 is 1. So the horizontal asymptote is y equals 1. Now what if instead of 1 over 1, what if there had been, let's say, just for the sake of argument, what if it had been 2x plus 4 minus 4 over 1x minus 3? Then the ratio would be 2 over 1, and your horizontal asymptote would be y equals 2 instead of y equals 1. Okay, let's move on. So we know that for every asymptote we have 2 limits, and we're going to talk about these limits right here. For the vertical asymptote, x equals 3, we need to figure out what's happening to the right of 3 and what's happening to the left of 3. So we have the limit as x goes to 3 from the right and the limit as x goes to 3 from the left. And the way we calculate whether or not we're going to get a positive infinity or a negative infinity is we take a number a little bit more than 3. Let's say we take 3.1. So go back to your reduced form and say to yourself, what is 3.1 minus 4? It is negative. It doesn't really matter what the number is. What matters in terms of figuring out the answer is whether it's positive or negative. And then on the bottom, 3.1 minus 3, well, that is positive. So we have a negative over a positive. Now the bottom is really, really close to 0. In fact, instead of using 3.1, we could have used 3.01, 3.001. Something really, really, really close to 3 is going to give us something really, really, really close to 0 on the bottom. And when you're dividing by something that small, you're going to end up with something really big, which means infinity, essentially. So we're going to have negative infinity. And then you'll see down here, I repeated that process for something a little bit less than 3. I used 2.9, plugged it into the top, it was negative, plugged it into the bottom, it was negative. A negative divided by a negative is positive. So that's how we know that that one is going off to positive infinity. All right, and then for the horizontal asymptote, associated with that, you always have the two limits that describe as x goes to infinity and as x goes to negative infinity. Those are describing end behavior. So what's the graph doing the further out you go sideways? And it's always doing whatever the horizontal asymptote says it's doing. So if the horizontal asymptote was y equals 1, then it's heading toward a height of 1. Those should always match. So now we have all the little parts and we're ready to put them all together in the graph. So I would start by drawing the asymptotes. So we have our horizontal asymptote, y equals 1. We have our vertical asymptote, x equals 3. And then plot the points. So we have a y-intercept of 0, 4/3. We have an x-intercept of 4, 0. We have a hole at -4, 8/7. And we have a hole at -3, 7/6. And then look at what your limits tell you to do. This limit down here tells us if you are to the left of 3, you should be going up toward infinity. So that would be this one right up here. And this other limit says if you are to the right of 3, you should be going down to negative infinity. So to the right of 3, go down. And then the other two limits tell us as you go further out sideways, you should be heading toward a height of 1. So skip over the holes, head toward a height of 1 over there and over there. And remember, when you don't have a point plotted in a certain region, go ahead and plot at least one extra point. And you're always welcome to plot more extra points if that helps you understand what the graph is doing. Okay, thanks a lot. That is problem number 98.